Hi everyone, this is part 2 and we're going to determine whether the following sequences have limits. These are the 5 problems we're going to do, so if you want to skip through and do one of these, you're welcome to do that. Okay, and I should have a parentheses right there. So we get started with number 1. So for number 1, if I write the nth term, remember this is a sub 1, a sub 2, a sub 3, a sub 4, and my nth term therefore would be negative n squared. Well, basically when you take the limit as n approaches a huge number of negative n to the square, you're just going to go to a negative infinity. Therefore, no limit exists. You can just tell by looking. That's just going to keep growing. So no limit exists. All right, and so the next one, we have a log. And the first thing I want to do is go ahead and condense this into a single log. If I do that, I'm going to write it as log base 2. And I'm going to use my quotient property. So I have n over n plus 1. Now, I'm just going to plug in points in this. So I'm going to just see what would be a sub 1, a sub 2, a sub 3. So if I just look at this part, I'm going to plug in 1, I get 1/2. If I plug in 2, I get 2/3. And if I plug in 3, I get 3/4. And you can keep seeing this is going to get closer and closer to 1. Not quite reaching it. So, for example, if I take, let's see, if I just say, therefore, just this sequence without the log of n plus 1, that converges to 1. So, now let's take the limit. So, with the limit, as n approaches infinity, of log base 2 of n over n plus 1. So we know this equals 1, so that converges to 1. So we have log base 2 of 1. And if you evaluate this, that's going to equal 0, mainly because 2 to the 0 equals 1 if you rewrote it as an exponent. Okay, so our answer is 0. The next one we have is this one, and I'm just going to let n equals 1, 2, and 3, and so forth. When you plug in that, you're just going to get 1, negative 2, negative 4, negative 8, and so forth. And that's going to keep going on and on forever. So no limit exists. All right, and this one, sine times cosine. Again, for this one, I'm just going to let n equals 1, 2, and 3, and more if you want. And when I plug in 1, I'm going to get 1 times 0. And when I plug in 2, I'm going to get 0 times negative 1. When I plug in 3, I get negative 1 times 0. What am I doing here? All right. This is times 0. And if I plug in 4, I'm going to get 0 times 1, and it tends to repeat. So this is going to be 0, 0, 0, and 0. Therefore, the sequence converges to 0. Right? The next one is tan, and I think I will do the same thing with this one. I'm going to let n equal, it's just easier that way. I'm just going to plug in 1, 2, 3, and 4. You can plug in more if you want. And when you plug in these ends, 1, 2, 3, and 4, what you're going to get is -1, 1, -1, 1, and therefore no limit exists. It doesn't converge to anything. And that's all. Thank you. Have a nice day. Bye-bye.